Hello and welcome everyone to National Drive Electric Week. Thanks so much for joining us early this morning. My name's Sandra Hall and I am a board member of the Davis Electric Vehicle Association and located in Northern California, and I'll be facilitating this session. First, I would like to let you know that this webinar is being recorded. If you have any technical difficulties, please just drop a note in the chat box and I'll do my best to help you. Then when the time comes, if you want to add your questions to the chat box there, that would be greatly appreciated. We will make sure we ask them. This session is being hosted by the Electric Auto Association, supporting EV education and the National Drive Electric Week. While this is the last day of National Drive Electric Week, there are lots of recordings that will be available of various sessions relating to choosing an EV, sustainable EV technology, EV basics, how plug-ins are shaping our future, like right now, and various EV incentives. So I definitely recommend checking them out. Now,
Sandra, the good news is that we actually not have just today, but we also have Sunday for another. There's sessions on Sunday, so we'll put the link to National Drive Electric Week in the chat box. So
fantastic.
And there will be, as you said, there will be recordings, and most of those sessions will be available afterwards. So if you even next month, if you go to National Drive Electric Week and you check that out, you'll find the locations where you'll be able to find a lot of the recordings.
Fantastic. Thank you for that. Well, next I would like to introduce Dr. Hoekstra, who is a research and senior advisor at Electric Mobility at Eindhoven Technical Institute and founder of ZEnMo simulations in the Netherlands. Dr. Hoekstra covers new findings in the CO2 emissions for EV manufacturing and driving and outlines mistakes often made in prior studies critical of EVs. Battery production emissions are dropping fast as production scales up and the grid is quickly getting greener. We'll also discuss why American emissions estimates are superior to European ones. Welcome, Dr. Hoekstra. I will pass it off to you now.
Thank you very much. Thank you very much. Well, I would say, I said in the beginning, we can make it interactive or we cannot make it interactive. It depends on the number of attendees. With not too many attendees, I would say, let's make it interactive if we can. So I will share my slideshow and tell a little bit about who I am and what I found, so to speak. But yes, I have that correctly. But I would also say, if you have any questions, please ask them right away and I will try to answer them right away. Okay. Is my presentation visual?
Yes, it is.
Okay. Let me just resize a little bit. Get rid of the black border. Most of the black border. Okay. So I thought it would be fun to tell about some things that created quite an interest on Twitter, where I have a lot of people following me who are interested in electric vehicles. And many of them ask, yes, but is the CO2 emission really that much lower than from a normal vehicle? Just first who I am, you quickly introduced me, but I think it's nice for people to know who they're talking to. So I have my own little simulation company. We basically make complex models of renewable futures together with two professors, the ex-CEO of a large grid operator, Peter Molengraaf, and a couple of enthusiastic consultants. I also started an initiative last year about basically calculating our way out of this climate mess. How can we adopt renewable measures as quickly as possible, but also at the lowest cost and with maximum effect? So that is a pretty large program, at least for the Netherlands, it's a large program with 35 new researchers that I'll be leading in the next 5 years. So I'll do more interesting things in the coming years than I've been doing so far. Maybe you should have me back in 1 or 2 years or something. But this is basically the backbone of my modeling. So this is for hardcore nerds that can look it up. Just use this link or just use the title. And you can find it. You can find everything you want to know about how I model. And now, with that said, I just want to give a little...
Kunnen we elektriciteitsconsumptie en netbelasting in stedelijke gebieden analyseren.
So, let me drown it out. So this is the kind of simulations I make. So they look nice, right? And we make neighborhoods, for example, simulate the use of electric vehicles, how that impacts the electricity grid. So we do quite, I would say, detailed simulations of this whole CO2 that I will be talking about. We also look, for example, what happens if the electric vehicle charges at optimal hours. Here you see that if one electric vehicle in 5 households shifts its load, oh no, sorry, this is one-on-one. So if an electric vehicle shifts its load, it basically takes away the peaks on the electricity grid. First, it makes it worse, but if you smart charge, it takes away the peaks. And if you do vehicle to grid, you can compensate for about 10 households. And here you see what happens to your electricity costs, for example, if you start smart charging. So I want to tell all this because the results I'm giving now are results basically for the current situation where everybody uses his electric vehicle in basically he plugs it in and he uses it. And I think in the future, we will charge electric vehicles at moments when the electricity is cheapest, but also greenest. And that future is still not in my assumptions here. So what I want to talk about, and I'm sorry, it's kind of boring, but maybe to look at scientific journals. But I would say to all of you, science still is working. You should listen to the science. I don't hope I make any enemies if I say that at this moment in time. But we really try to do our stuff as to our best of our abilities. And this was a study I did, or an article I wrote about CO2 emissions that you can look up for yourself. I also did a new study recently that is maybe easier to read if you want to dive into the details, and I'll be using that. And I'll skip over this because I want to talk about the 6 biggest errors that most people make when they underestimate the CO2 emissions of electric vehicles. And the first big error they make, by the way, I cannot see it right now, I think, if people ask questions, because the moment I shared...
We can bring them to your attention when the questions come in, if you'd like.
Yes, I would like that. But also, yeah, now I can see a chat window. Ah, yes, I will definitely share them in a few years. Okay, that's the deal then. Okay, yeah, I see the window. So if anybody types in here, I don't know if we have still one guest, please type in something, or more guests, we'll get into more details. So the first error that a lot of people make is they say the production of the battery is so, causes so much CO2 emissions. The battery production is such a big problem that basically the electric vehicle can never earn back what was lost during battery production. And actually that used to be the case with the first batteries. But batteries are changing very, very, very fast. So the number you have to look for there is how many kilograms of CO2 were emitted with every kilowatt hour of battery production. So for example, the biggest Tesla has a 100 kilowatt hour battery. So you would take the number of kilograms per kilowatt hour of battery and multiply it by 100 to get that. And what we saw in the past is that many people use 175 or 200 or 300 kilograms of CO2 per kilowatt hour. Right now with the, for example, the latest report from Tesla, but also many different other studies that I used in the study you can download using the link I just showed you, we come to around 75 kilograms per kilowatt hour right now. So that's a very important number to remember. And basically what that means is, yeah, within 20,000, maybe 30,000 miles, you will have earn back that battery if you drive in a really big car, maybe even faster. The second error that many people make is they underestimate how long batteries last. For example, the first Leafs that drove around in California, they had problems, to be quite honest. They had problems because they had just air cooling, passive, or a little bit of active cooling, a little passive cooling. In the hot California climate with early day batteries, that was not a good look. So these batteries degrade a little bit faster than usual. But right now, the newest batteries, what we see is, for example, for Tesla, is that they easily last like 500, 600, 700,000 kilometers. So in miles, that's about, let's say, easily 400,000 miles. And that's more than most cars last. So right now, batteries easily outlast the cars. And there's talk of them going towards 800,000 miles, sometimes even. So batteries, good news there. Another thing that almost all studies do wrong, in my opinion, I think you should be realistic and basically you should ask yourself, how much will my car emit over its lifetime? And preferably, I think you should look at your own electricity mix and input that in the equation. And I wouldn't mind helping you out a little bit if you find that problematic, but it's fun to do. What you will find if you use the average mix, electricity mix, is that over the lifetime of your car will get cleaner and cleaner and cleaner the longer you drive, because the whole electricity grid in the world everywhere is greening. So if you take that into account, you can easily find that you emit, let's say, 30%, 40% less CO2 over the lifetime of the vehicle. Right, so details in the study, but I'll go over them quickly here. And then error 4, there's only 6 errors, so we're mostly there. Error 4 is that many people use laboratory tests instead of real world tests. And in Europe, that's the part where I said that European measurements were inferior to American measurements. I know that in America, the EPA is under threat, I would almost say. But right now, for example, when they measure the emissions of cars, they are doing a really good job. They basically are doing independent tests. Now, you would say, how hard can it be to do independent tests? Well, very hard in Europe. In Europe, there is such a close collaboration between car makers and politicians, and also because of the constellation in the European Union, they work together closely. Working together closely is a good idea in itself. But right now, the tests that we are doing are all paid for by the manufacturers. So the manufacturers chooses a certain car, grooms that car for testing, optimize it in every single way possible, gives it optimal software that is optimally suited to the test that will be done, tapes off all the how do you say that? Uses a lot of tape to make the aerodynamics better, pumps the tires full of everything, puts in a driver that is really, really good, and then we start testing. And right now, the tests, last year the tests were about 40% to 50% more optimistic than reality. And this has been going on for a while. And now we have new tests. The old tests were called NEDC, New European Driving Cycle. And the new tests are called VLTP, Worldwide Harmonized Testing. But there's still 20% or something too optimistic we see in most cars. So it's important to take good tests. Unfortunately, in America, that's standard, but in Europe, it isn't. The fifth error that's often made is that the fuel production is simply forgotten. Sounds strange because we all know by now that electric vehicles, they do emit CO2, right? They don't emit it at the tailpipe, but they emit it when the electricity is produced. And even if you use solar cells, you have to include a little bit for the production of the solar cells themselves, or the production of the windmill if you use wind, that sort of thing. But people on the other side often forget that for gasoline, the same is true. The gasoline doesn't just grow on trees. You have to produce that with oil as the basic product. And that easily adds 24% of CO2 emissions to diesel and about 30% to gasoline. So never forget that. And finally, people often ignore the big picture. And what I mean by that is that we're in a transition. So current values are actually not that important. Currently, we have a small amount of electric vehicles, and they already outperform normal vehicles a lot, as I will show in the next slide. But that's not the point. The point is, once we start going to 50% or even 100% electric vehicles, how will they compare then? And the good news, of course, Elon Musk, you can think what you want of him, but he's done quite some, I would say, impressive things. And he agrees with something I've been saying for, I think, 6 years now, that in the end, once you produce windmills with windmills and solar panels with solar panels, and you start producing, mining using those windmills produced with windmills, and you start, you use your factories using windmills and solar panels. Once you do all of that, then CO2 emissions basically go to pretty close to zero, at least 10 times better than they are now. So that's the end goal. We're in a transition from now to that end goal. And when you say, yeah, but diesel is not that much worse, so, and it can get 10% better or something, so let's stick to diesel, you're really missing out on a big picture that says the CO2 emission of electric vehicles will get 10 times better. So that's 90% better, not 10% better. So that's the reason I'm very enthusiastic about electric vehicles, even though I think that car sharing, not driving an SUV, but a little bit smaller car, or even biking, as we like to do in the Netherlands, are much better for the environment than driving a car. Still, driving an electric vehicle is much, much, much better, especially regarding CO2, than driving a normal vehicle. So the end result, they got a lot of play in Germany, as you can maybe understand, is when I compared a Mercedes C22D for diesel. It's one of the cars they're really proud of in Germany, and basically corrected all the errors that I just listed. Then I saw that the manufacturing, excluding the battery, already added about 32 grams per kilometer driven. And this is assuming, by the way, 250,000 kilometers driving. But okay, so then for every kilometer driven, I'm sorry, I'll try to do miles, but it's not in miles. So for miles, it would be about 20 grams per mile. And then the driving itself would be, I think, about 180 grams per mile. And then the total emissions of the Mercedes would get below, oh no, shit. Now, if I do grams and miles, it becomes very complicated in my head. So I'm very sorry, really sorry. But I'm going to do grams and kilometers. So that's 260 grams per kilometer. Now, if you drive a Tesla Model 3 right now in Europe, but also in America, actually the average in America and the average in Europe are not that different, then you see that the manufacturing emissions of the Tesla Model 3 are actually a little bit lower because you miss the drivetrain. The battery adds a lot, so there's 23 grams for a 75 kilowatt hour battery. But then the driving is so much less that right now you emit about 90 grams per kilometer with a Tesla and 260 grams with a Mercedes. Now, a lot of people were not happy when I said that, but it's the truth. You can even make it more extreme. If you take a Porsche Taycan, but you could also take, by the way, a Tesla Model S Plaid or something that uses about the same amount of energy, then your emissions would be much higher with the electric vehicle, around 140 grams per kilometer. But a comparable sports car is an incredible gas guzzler, because if you have a really large motor, then in normal use, it's incredibly inefficient. With an electric vehicle, is that in that case the difference is really extreme. So yeah, it was a kind of a boring talk, but I thought let's stick to the title that I promised you guys. They emit much less CO2. And yeah, now I hope that there are critical questions, and I'll look at the chat window now. And I see Sandra has also asked a question. Oh, no.
Yes, I had a question for that first calculation when you are comparing you were talking about the errors. Yeah. The lifetime battery is there like a particular year that EV batteries got better, that when we're looking at purchasing maybe a used EV, you could be like, okay, so 2015 is kind of where the 30,000 miles gets better, or okay, no, we're at 2015, you have to be at 60,000 miles for it to
that would create a funny situation where you like a wine. Is this a good year for wine? Is it a good year for cheese? Now, yeah, I would say newer is better in that respect, but actually, I would say that's the wrong way to look at it, because if you buy any second-hand EV, then on the one hand, older batteries might actually have produced more CO2 when making them, but they would also be longer in use already. And yeah, one, of course, unfortunate, or at least for EV lovers, unfortunate but hard fact is that if you don't drive a lot, then keeping, for example, your old gas guzzler and driving it for, I don't know, a few thousand kilometers a year is probably better than buying a brand new car, right? It depends, of course, on the amount of emissions, and if it's a really dirty one, then also for your neighbors or etc. You could switch to electric. But building an entire car is a lot of work, and for that reason, driving a second-hand EV, I think, would beat almost any new EV. So if you talk about an old EV, you're talking second-hand, and I would always say that's probably from an environmental standpoint a really good move to make. So yeah, that would be my answer. And I don't exactly what I can tell you, but I would not use that in buying decisions. Is that right now it's 75, and I think it's realistic to say that it was double or something 3 or 4 years ago on average, and a lot more before that, and it's still going down pretty quickly. So that's sort of the curve in my head. Is that sort of an answer?
Yeah, no, that's a great answer. Thank you, and thanks for bringing up the fact that buying used EV, no matter what, is probably better. Very true.
I see a Robert, by the way. Saying, sad we haven't yet converted to the use of the metric system. I can only say that as a scientist, I love that I can use the metric system. It's really easy to use, but of course I will never tell anybody, you know, what to eat or what kind of, yeah, it's a personal preference that you get through growing up, but it's super easy if you have six basic basically metrics, and everything can be expressed in those 6 metrics. But yeah, actually I might have tried to convert them. So sorry, Robert.
We do have some other questions here. One from Guy. The driving emissions in your chart includes fuel production?
Yep.
All right.
Yep.
Any insight into other emissions such as PM 2.5?
Well, that's a different can of worms, I would say, because I actually have, I try always to get medical students to look for that more specifically, because right now what we're seeing is that, of course, tailpipe emissions of an electric vehicle are 0. And they can be quite big, especially in older vehicles, especially in older diesel vehicles, for example. And then especially the PM 2.5 emissions can be really bothersome. But on the other hand, if you just look at the weight of the emissions, just count the micrograms basically, then a lot of emissions also caused by the tires. And there you see that electric vehicles at this moment actually emit a little bit more, not very much more, unless you're driving a new very powerful EV and you want to test it out constantly. We see that a lot in Tesla data, by the way, but once people get used to it, it becomes normal again, the tire wear. Of course, the brake wear becomes a lot less too. No emission, but I think the most important thing, and we're still not, as an EV community, are doing our best to put it front and center, is that the really awful, as they call carcinogenic stuff, the stuff that gives you cancer basically, you cannot equate that, I think, with rubber from tires or with sand. And we're doing it right now. So PM 2.5 is actually a little bit better for electric vehicles, but the difference is not as stark as you would have liked or would expect, because it's mostly sand and tire dust, actually, tire wear. Is that an answer?
Yeah, that's good. Thank you. Another one from him. What assumptions did you make on the rate of greening the grid?
Yeah, in Europe, I have used the assumption that over the lifetime of the vehicle, it greens with about 9 grams per year. So that's basically extrapolating from the last 20 years or something, rather constant. And that over the lifetime of the vehicle, then in Europe would give you 250 grams per kilowatt hour. And I don't know how, yeah, so in LBS it would be, so it would be 0.5 LBS per kilowatt hour, right? I think. But anyway, that's what I took. And I think it's comparable in the States, although it's of course very different from state to state. Actually, some red states are doing great with winds like Texas, but that's an aside. Yeah.
How should we adjust the estimates between dirty and clean states, would you recommend?
Yeah, well, it's almost, the problem here is that there is not one definition that everybody will sort of agree with. For example, I think that I live in a house that is basically made of wood. So in the building of this house, only CO2 was absorbed. The solar panels, of course, did emit a lot of CO2, but my whole roof is solar panels. If I take my solar panels off, it gets leaky. It's really whole roof solar panels. That means I produce much more electricity than I use. Yeah, but a lot of people say, no, you still have to use the average electricity mix in the Netherlands. Yeah, I basically don't think so. I do it to not to be snobbish or not to seem like an evangelist too much, but I think that you should look at your personal purchase agreement. In most states, I think you can buy green electricity, or your boss can buy green electricity, and then you should use those in your equations. I think that's the neatest way to do it. But of course, yeah, you can also look, for example, at the Gigafactory. They often use the average mix of Nevada, which I don't know by heart. So you can look and see that there's actually a tool, and I forgot the link to it. I think it's of the Union of Concerned Scientists. Not sure. And I think they have a tool that you can compare CO2 emissions of your vehicle in different states. You can simply input your state and look at it.
Very cool.
By the way, this is Guy. I'll follow up on that answer. You're right. The Union of Concerned Scientists does have a tool to give you different numbers between the states. But it seems that you might want.
I think they're still pretty conservative, in my perspective.
I was thinking that. I thought that it might be worth. Are you in touch with them at all to share some of your findings with them?
Yeah, actually, you know what one of the nice things about us having a chat now is that it might lead to some people reaching out and getting in touch or something, because yeah, it sounds strange, but even though we scientists may sound like we're sort of a club tribe to other people. I know I don't know anyone who is with the Union of Concerned Scientists, even though probably some of them follow me on Twitter, and I might even follow one of them. I don't know. But yes, it would be a good idea, I think. I worked also together in Europe with Transport and Environment. And their tool is now updated with my latest findings and become more optimistic and according to them and according to me, of course, better sourced and better substantiated. So I would love to do that with the Union of Concerned Scientists, if you know one, if you know someone. Mm-hmm.
So I don't know anybody, but if anybody out there does, please let us know.
Yeah, we have some contacts so we can connect them together. And I see Robert has a question.
Yes.
Ah, Robert. Let me see.
So he's asking, many new battery technologies are currently under development. Which of them would be best for reducing the CO2 cost of manufacturing the batteries?
I don't like to be a Tesla fanboy because, yeah, for me, it's all about electric vehicles and Tesla is just one producer. Yes, thank you, by the way, Sandra. That was the tool. Yeah, the tool is now in the chat. I think a couple of things they proposed at Battery Day were actually are really promising, and basically they spoke of all the all the regular innovations that a lot of people spoke to, and they made certain decisions there. Now I don't know if the decisions were right, but they, for example, they were saying, let's replace the graphite with the silicon. Well, that would make batteries lighter, and lighter is actually also saving you money. So that's a really nice one. Getting rid of cobalt in the cathode is a development that a lot of people are working on that would also reduce the price quite handsomely. What I really liked in terms of reducing battery costs is seeing the battery more as part of the entire car. And for example, that also means that they're also structural right now. So, so the idea is to make them structural. I've been also saying this for years and years and years, but of course I don't have an engineering team to actually make that work for a new vehicle. And Tesla did and finally said, let's basically glue the batteries to the bottom structure and use glue that can also beat back the flames a little bit. And then your batteries themselves make the whole structure very, very rigid. So this is also a way to really reduce cost. Of course, longer term lithium sulfate is a really, really good candidate. Solid state could be a way. A lot of companies believe in that, but who will be the winner is yeah, I think nobody knows right now. Oh, and now we have also a question from Dale Page. I hope that's the best answer I can give. And we have a question from Dale Page, I see. Maybe you should read it, Sandra.
I was on mute. Yes, Dale Page says, I am also interested in information about the relative operating costs of EVs versus ICE. I'm interested in the acceleration of degradation of EV batteries used in vehicle-to-grid applications and management technologies towards reducing degradation in vehicle-to-grid application.
Aha.
So
so then I have really good news and really bad news. Let's start with the bad news. As far as I know, you must be a handyman with a soldering iron, willing to give up your warranty to make your car do vehicle to grid. Nissan might be the exception or a no, but and then you would have to use a special charge point at home using the ZEnMo protocol. So vehicle to grid is a little bit off in the future right now, but I think definitely it's going to come to be the future. Actually, I'm really bullish on it for the reason that Dale's also hinting at. In the past, so first of all, vehicle to grid, for those who don't know, is basically that you uncharge your vehicle into the grid. So you can do it both ways. So then you are really a battery on your car, really a battery on wheels. And actually that battery on wheels will be a great asset to have in any energy system that has a lot of wind and a lot of solar. Really important added benefit that could be. And it could also, depends very much on the electricity grid, could make you a lot of money, like, well, a lot, like 500,000, in some cases, maybe $2,000 a year. I would say that's actually, yeah, it could in some situations also be less than $500. But the reason it's not been done so far is that it degrades the battery faster, because all this charging, discharging make sure that the battery is used much more frequently than it used to use. I mean, if you have normal, for example, if you have a car with a range of 400 kilometers and you drive, let's say 250 miles, and you drive, let's say 50 miles a day, then you basically use the battery every 5 days. Every 5 days you will have used 250 miles, and that's basically you have rotated the battery every 5 days. But if you do vehicle to grid, well, you might use the battery once a day or something. For example, charge it during the day with solar power and then discharge it during the evening and night. That would be more cycles, faster degradation theoretically of the battery. But what we see with newer batteries is that they can probably easily handle that. It's early days, because the only real way to know is, of course, observe those batteries for a long time in practice, like years, and then you know if you can really do that. But it's looking good, and that will be really a game changer for wind and solar. So I think in the future you could earn, yeah, let's say $2,000 per year, maybe 2,000. With your battery, and the electricity would be very happy. Yeah, Guy is adding to that, and let me echo that, by the way. But it's true. One of my students did a master's thesis on vehicle to grid. I think one and a half year ago. And a German study had just been, in a journal, had just been published, which basically said vehicle to grid can prolong your battery life. Was really like, what? Can't be true. But basically what their position was, is that if you make the average charge of your battery less, so if your average change of charge of battery is lower, then your battery lasts longer. So to make it simple, if you have a lot of batteries, electric car batteries on the shelf in your house, it's better to keep them, let's say, at 20% or something of capacity, and charge them now and then so that they stay at 20% of capacity. Should never get to zero. That's a problem. But 20% of capacity, they will last longer than if you keep them on the shelf at 100% capacity. So if you do vehicle to grid, you could basically uncharge your car when you come home, then charge it up again before you leave, and on average, it will be less charged. If you combine that with, actually this was not the biggest effect, but it was a nice, interesting effect, of course, because this was something that actually positively influenced by vehicle to grid. But there's two other effects that is also really important. First of all, don't let your battery get too hot. If you avoid that, if you stay very close to a room temperature, then your battery can last a long, long time. And second of all, stay between 20 and 80% of charge most of the time. Don't charge too quickly, especially when you get to the end. And then basically the impact on your battery life is almost negligible. And new battery management systems are smarter and smarter at using that sort of intelligence, in their algorithms. So yeah. That is the future. I really think that's the future, but it's not something you can buy right now. That's what I can tell about it. Yeah, and then Dale says, can I read it, Sandra?
Yeah, if you'd like.
Well, actually, your English is better, but okay.
I can go ahead. Also, if battery is part of the car chassis, then they would not be able to swap the battery. Does this impact choice of battery in vehicle versus stationary consumer battery?
Well, right now, of course, battery swapping has never really come off the ground. We used to have a company, and when I started writing about electric vehicles, this was really our hope, because fast charging was not that fast, and battery swapping would be the way to sort of fast charge your car, and then Better Place was started. But in the end, Better Place went bankrupt. And battery swapping is not done right now. It would be nice, I think, if your battery breaks, that you could replace it. So that sort of swapping seemed interesting to me. And also at end of life, I think it would be real handy to have the ability to take the battery out. So there's something I do worry about a little bit with the structural battery, that basically you have to scrap the battery, and you can recycle it, and that's nice, but you cannot easily give it a second life unless you basically use the entire structural battery. So basically you say, okay, this is, for example, this Tesla is now ready to be scrapped. Let me take off the entire chassis and sort of build out the battery and use that. But yeah, this is all future. We really don't have a market right now unless you're really a do-it-yourself enthusiast. But maybe all these questions from Dale, maybe he is the kind of guy who can use a soldering iron and reuse parts, and then a structural battery could be problematic. Now,
Dale, would you be interested in coming off of mute and asking any further questions you might have related to this?
Well, can you hear me?
Yes.
yes.
Okay, yes. I think you covered it well. I kind of beat the vehicle to grid into the ground, but that's a big conversation that we're having here with respect to pushing peak demand off of peak and into the evenings here in California.
Yeah, it's super important, by the way. I'm a big fan of that. So if I push that into the ground, that was not my meaning. Actually, in Holland, I'm known as Mr. Smart Charging, also, at least, because I think it's so important to do that. So this whole duck curve can basically be obliterated with vehicle to grid.
Right, and so that's exactly why it's a important discussion. Also,
Yes.
listening to Tesla and Elon on the battery day, they're not so hot on vehicle to grid, and they were advocating, okay, get a stationary battery and you have the battery in your car for that purpose. And the chemistries might actually be different. I don't know too much about battery chemistry, but perhaps that's you know.
Yeah, but yeah, that's also a long-ranging discussion. I'm not sure. So I usually take people at their arguments, but since so much is proprietary, not known here, that's a bit hard. And I have to point out, it's kind of tricky to tell people that if they buy your car, they don't need a stationary battery anymore. So there is some potential for confusing in the commercial setup there. Let's put it that way. And also, yes, of course, the chemistries will be different, a bit different. But in the end, if you have a battery that can really do, let's say, 800,000, let's say 500,000 miles or something, and that is what we're seeing right now in the Tesla batteries that are tested by owners, then it's very hard for me to see how you can quickly make them really old with vehicle to grid. I think it seems that those batteries, I mean, in the end, it's electrons, right? So if you manage them carefully, you can of course use them less vigorously maybe than a home battery, but actually it's really big, right? So if you have a 100 kilowatt hour Tesla battery in front of your house and a 10 kilowatt hour Powerball, then it will be very hard to abuse the 100 kilowatt hour battery with the kind of power that you feed into your 10 kilowatt hour Powerball. So I think there's potential there, but yeah.
Well, and that's one of the critical things is discussion about how appropriate management of the use of the battery could minimize the degradation of the battery in that application. So that's something that I learned from your discussion.
Absolutely, absolutely, and the difference is enormous. So basically, the battery on your phone would also last a really long time if we didn't have the habit of always charging it to 100% at night. And actually, I think most phone producers don't mind very much because they want to sell us the next model in 2 years' time or something. But the thing gets hot. We charge it to 100%. They get abused much more than car batteries because car batteries have a much better battery management system. And also, for example, a nice, what I like about my Tesla Model 3, for example, is that usually I can set it so that it's not completely charged. So I charge it to 70, 80% usually. And only when I want to make a longer trip, I charge it up to 100%. And that really prolongs your battery life, which is already long, hopefully. So yeah, that's really important. So, but basically, bottom line is we can develop better vehicle-to-grid algorithms that go really soft on a certain battery chemistry, and I think it's really important we don't use too many resources, so we don't basically use more batteries than we need anyway. So that's my take on it.
Well, and as long as I have the microphone, one thing that I don't really know is the relative cost of operation as the consumer of my Tesla 3 or whatever electric car you're driving versus the ICE vehicle costs of, the Tesla makes a big deal about that there's a benefit there. But when people ask, I can't really tell them because I get free charging on mine. So I don't really know what it costs me when I'm traveling across the country. So.
Well, it's actually, I don't know your numbers exactly, but what you can on average, you can look at fueleconomy.gov and see what the fuel use is, of course, of one vehicle and what the electricity use of the other vehicle. So on the average in Europe, but it's Euro prices, the advantage is about 11 to $12 I would say it's less in the United States because your gasoline is cheaper. But you basically, I would say 2/3 of your advantage is in energy. So just see what the gas guzzler uses. You can calculate it, right? Mile per gallon and so. And then you take your electric car.
There is a good site to help with those kind of comparisons at plugstar.org or plugstar.com. So that's
Plugstar.com. It sounds familiar. Yes.
Yeah, they they list all the different EVs and the latest prices in the U.S. Also, they do it based on your zip code, what's available to you in a zip code area. But as part of that, you look and compare those different EVs. They will compare them to the economics on a gas car, an internal combustion engine, with the EVs that you're looking at. So check that out. Before we wrap up here, I think, do you have some contact information people should use if they want to check with you or your teams for additional follow-on questions or another presentation in the future?
Yeah, the easiest way basically to reach out to me is ask your questions on Twitter. Honestly, it's just my name, Auke Hoekstra, can't miss. And then some other people can also find out the answer to your question, which is fun. And you can also mail me at, I should have put that online. It's pretty hard. It's pretty easy if you Google me also, but it's the shortest one is Auke. So my first name that you see there. And then at ZEnMo, so my company you saw in the beginning, So if you mail me there, I'll mail you back.
Excellent.
I can also put it in the presentation, and you can send the presentation, maybe put the presentation online or something. I don't know.
All right. We'll do that. Thank you for sending that. We'll make that available to those people that registered. So, Sandra, do you want to wrap us up?
Sure. Well, just again, thank you so much for this wonderful presentation and answering all our questions. I'm very excited to share it with some of my colleagues at the Air Quality Research Center who also drive electric vehicles.
Yeah, actually, Sandra, actually, sorry to jump in, but if there's anybody from the Air Quality Research who would like to work together with us on a new program we're doing, the NEON research program, big research program for basically the future of renewable energy. But I talked a little bit about it in the beginning, my second slide or something.
Is that the new paper that you just put out?
No, it's the new program that I'm kicking off.
Okay.
Actually, I kicked it off last Wednesday, and I had to switch from in person to online at the last moment because of COVID. And that was because, and for that reason, we had to do the presentation now instead of last week, actually. So that big program, and I could really use people who really know air quality research. And I could give you guys everything that sort of is around that, so to speak. So when do you use the vehicle? How much can we expect the vehicle? You know, how much of which kind of electricity sources will we see in the future? But the impact of the stuff once it leaves the tailpipe, for example, or the smokestack, that is a very specific discipline that's hard to come by. So I guess you guys, I see air quality research, know about that kind of stuff. So that would be really helpful.
Yeah, I could reach out to some of our members and see if anybody's interested.
I would love that.
Great.
Okay.
So when you share the slides, I'll be able to share that. Yeah.
Yeah, I'll send them to Guy just after the presentation, just right now.
Perfect. Awesome. Well, thank you again for, like I said, the wonderful presentation and answering all of our questions. I just want to share for all of our attendees again, this session has been hosted by the Electric Auto Association supporting EV education and National Drive Electric Week. If you have not checked out the other events that are happening Sunday, as well as some of the recordings that have happened this past week, we will be sharing that information via email for the recordings. And you can check out the driveelectricweek.org for information on the upcoming sessions as well. Other than that, thank you all so much for attending, and we will hope you learned lots. Have a wonderful day.
Bye-bye.
Bye.